In this example, we're looking at a wind farm project within a forestry region in New South Wales Central West. We've loaded 5 assets into the project. These are all turbines, number 1, 2, 3, 4 and 5. You can use our tool firstly to measure or estimate fuel loads across the project area. So the way we do this is by combining a fire history layer, and in this example, this region hasn't seen a fire history. There have been no historical fires in the region. And we combine that with our vegetation layer, and we see the vegetation is said to be acacia open woodlands and sparse shrublands in the surrounding areas, and within the plantation itself, modified forest. That modified forest actually has been entered in by our revegetation capability, which enables users to account for any modified land uses, such as forest and pine plantations in this example. So we've modelled that forest in to make the tool more accurate for the exact scenario that we have here with these wind turbines. From those layers, we have an estimated fuel load layer. You see 12 tonne per hectare throughout the forest, a bit lower outside the forest at 10 tonne per hectare for the most part, except for the densely wooded areas where it can get up over 20 tonne per hectare. We've loaded a fire simulation under very high fire danger conditions with southwesterly winds blowing. We have a risk from layer, so this shows where are the worst fires predicted to start according to that simulation under these conditions. And so you see, for example, in these red areas, you can see down in the bottom left corner as I hover on them, that fires here are predicted to spread to about 140, 145 hectares within the simulation period that we've run. And in this case, that's an 8-hour unimpeded fire spread. Over here, it's a bit lower, 60s, even 45 hectares for some of those fires within those 8 hours. We also have a risk 2 layer, which shows which areas will be worst hit if a fire was to occur anywhere in this location. So based on the simulation conditions, where would the fire most likely go? And finally, we have an inspection layer, which enables us to click anywhere on this map and say, all right, where are the fires going to start that will impact this location under these conditions? And so we can select our turbine here, for example, and see, okay, any fires that start in any of these cells are predicted to impact that turbine. Finally, we can also select here and say, okay, where will fires starting at the turbine actually spread to? And so we use this feature to say, okay, what if there's actually a risk from the infrastructure in question? Where will that fire go? So now that we've observed the predicted fire behaviour and identified our risks, let's set about trying to put in some mitigations to protect this turbine from being impacted. We've already actually loaded these. If you open up our treatment layer, we've modelled a mechanical understory thinning within the asset protection zone around that turbine, and then a larger, less thinned, higher fuel load outer asset protection zone. And we've modelled those for the first week of March this year. We've also modelled in a mitigation down here just to impede any fires coming from that southwesterly direction. If we skip forward in our calendar now to April, let's say, and rerun our simulation and observe the fire behaviour, we predict the fire would behave in April under the same conditions, except now those mitigations that we just spoke about have actually been put in place. We'll see how those mitigations impact the predicted fire behaviour. Now that this simulation's finished running, we can once again look at the risk 2 layer and see that the mitigation we put in the asset protection zones around this turbine have completely mitigated the risk of impact to the turbine. We can look at our fire spreads again and model how they will behave and actually observe what will happen now as the fires approach the turbine and see how the mitigation actually is so effective at deflecting that fire around either side, providing fire crews time to actually get there and potentially save the asset. Secondly, let's now look at the risk from the asset, this risk from layer, and we can observe how fires will behave if they actually originate at the turbine. And we can now see that any fires starting at the turbine really struggle to get a run going. And once it breaks outside that mitigation zone, it does start to run off, but it's much slower to get going, and again affords crews time to get there and actually stop the fire. And so by using these techniques, we're able to continue building mitigations, scheduling them out over the years, and perform them at all of these assets to protect them, model what the risk will be to our assets over the coming years, and then export a bushfire management plan that we can follow in the coming years to keep our assets safe well out into the future.